Hello and welcome to the Roundtable Podcast. My name is Shogun. Joining me today is my friend Hank Hill, an expert in the subject of flat Earth and all the questions surrounding the Earth-shaped debate and the problems, anomalies, and questions around the heliocentric model and its alternatives. So before we get into this and the free discussion and debate to follow, please make sure you've joined us on the Roundtable Discord server. We record special events every day at 9 p.m. Central. You can see upcoming events in the announcements channel and all our hundreds of great past special events in the hashtag RT podcast channel. Check out the YouTube and BitChute channels there. That being said, welcome Hank Hill. Thank you so much for joining me. How are you, my friend?
Good. Yeah, thanks for having me on here. I really appreciate the opportunity to get to speak my mind and share information. So thanks very much.
Thanks so much for joining me. So please just take us through this journey in whatever way you think is appropriate.
Yeah, so first of all, I would just ask everybody to be open-minded. Science is never settled. Like, it's not like a religion, right, where you're like a heretic if you're outside of it. In fact, most scientists are supposed to be outside looking at things from outside the box, and that's how new information is found. But not everything is science that appears to be science, and that's the problem with today. We find ourselves we're in dire need of a reformation of science, because what is it, right? Is it just knowledge? So can I just say, well, I know how many toes that I have, right? So that's science? That's not exactly how it works, right? So I just want to go over, the basic fundamentals of the scientific method, also known as natural science, right? So the way that it works is that if you have a caveman, he sees a hot spring, water boiling. Well, what causes that? He comes up with a hypothesis. Maybe it's the heat, right? So he goes and he tests it. He adds heat to some water. It boils. It stops boiling when he takes the heat away, and it boils when he does it again. So what did he just show with the scientific method, right? He just showed that you make observe a natural phenomenon, right? The water boiling, right? And then you form a hypothesis. Well, what's the hypothesis, right? It's the independent variable, that thing that's causing the naturally observed phenomenon. And when you turn it on and off like a light switch, 0, 1, 0, 1, you can see the cause manipulating the effect, right? So it's kind of like going into a hotel room. You've never been there before, and you flip on a light and you go, oh, that's my side, right? And then you think it's settled, right? But then the other person in the hotel room with you, they flip the switch and it affects the same light. So there could be two causes to the same effect. For example, with the water, if you put it in a vacuum, it boils at very low temperatures, right? So the science is never settled for this reason. So we're always like 99 point something % sure this is the cause of that, but it's never settled. So what we have here is like a really old argument over the shape of the Earth, but it's never really been settled. And the reason is because it's not science, right? This is geometry. We're measuring the shape of something. So really, I don't think we should be called flat earthers. I think they should call us flat waterers, because what we're doing is we're going out into the natural world and we're measuring over water. And the best way to do it, obviously, is, still water, right? That's, not a whole lot of waves, not during the tides. And what we're seeing is that we can see too far. Now, I would ask everybody to participate in this part, because this is really interesting. You can search right now, what is the radius of the Earth, right? And then they'll tell you, Google, whatever search engine, they'll tell you what it is, right? And then you can go to an Earth curve calculator right after that, right? So it's 3959 miles. You go into an Earth curve calculator and you type 1 foot observer's height, or eye height, and you just look at the horizon distance, and it'll tell you where the horizon should be, because we can work it out mathematically. So if we can do that, then we can actually measure it for ourselves and falsify it. Now, see, here's where science really becomes important. You got to pay attention to this part. If you're not doing the scientific method, then it's not a scientific theory. And if there's no science involved, well, I could just dismiss it as poetry, right? Because anybody can say anything. Any village idiot can describe something and explain why he thinks this is happening, but you don't really know until you manipulate the independent variable and you see the cause and effect relationship. That is where you know something is true. And what I find, a lot of people are just going around committing all these false cause fallacies. So it's like this. How do you know the moon's gravity is affecting the tides? You can't manipulate the moon's gravity to see the cause and effect relationship. So it's just something that's widely accepted that nobody really knows what's causing it. I mean, you could say it has to be the moon's gravity, right? But that's a fallacy. What if it's the sun's energy? Just for example, like we haven't tested it, so we don't know which one it is. Both are equally true. Now, a lot of people will say that, it's knowledge that they have that the Earth is spherical. Has they been out there and directly measured it? If you haven't directly measured it yourself, you believe that someone else has done it. And if you believe that someone else has done it, well, you're just believing what they're saying, right? So it's a belief that you have that it's spherical. It's not an actual knowledge type thing. So what you have to do is you have to ask yourself, how do you know? How do you know these things? How do you know that if you measure the curvature over the water, which it should be 8 inches per mile squared, then you should be able to measure yourself and detect that. But the thing is that all over the world, people are doing this with different apparatuses like lasers and flashlights and mirrors and telescopes, long zoom cameras. And we're all agreeing that we can see too far, right? So the question is why? Why are we seeing too far? Well, the flat earth is going to say because the earth is flat, or at least it's not the size of the sphere that they told us. Maybe it's much, much bigger. And some of the measurements I've seen with the black swan indicate that it could be the earth's radius could be the what was it? Like the moon's circumference, 238,000 miles away. Like that would be a really big earth, and they would be hiding a lot of land, and this whole global warming thing wouldn't really make sense under such conditions. So what we're trying to figure out is if the earth isn't curving anywhere, well, what is it? Well, you would say that's what you call flat. That's what we'd say it's flat. So you believe that it's spinning because you see the stars in motion, but according to classical relativity, all motion is relative. So how do you know it's the earth spinning or the stars spinning or the earth going around the sun or the sun going around the earth? You don't. You can't tell. It's relative motion. So ever since you stepped foot in kindergarten and they started saying, you live here and the sun is over there and we're spinning, that's not really true, is it? Like, we can't verify that inside the solar system. You would have to have a third reference frame outside of the solar system and observe the Earth from there, and which you can't do. So because you can only observe the Earth from here, well, we all say that it appears geocentric. And that's what we all witness. Sun, moon, and stars make an orbit overhead roughly once every 24 hours. So you might believe that this is settled science and the Earth is spinning, but science has never settled and it's never been proven. So you might believe that someone else has proven it, but that's just a belief that you have because you yourself haven't done any test or experiment, and there's none that you can do to prove it because nobody can feel it, nobody can measure it, nobody can falsify it. And Karl Popper, he was all about if you can't falsify it, it's not science. So he was really into that, it has to be empirical, it has to be testable, it has to be repeatable, but most importantly, it has to be falsifiable. So the third claim is that if you go high enough, you can see the vacuum of space, right? So if you just keep going up and keep going up, you'll see it turn into a sphere. You'll see it start to spin, and then eventually you're in the vacuum of space. And we all know that you can't buy propane without propane accessories. I mean, Hank Hill said that on his show every single time, without fail. Got to have the propane accessories, man, because you can't just take gas pressure, right, and put it in a vacuum without a container. If you got a vacuum, you got some sort of container that you've used to create that vacuum. And we can't have high pressure systems sitting next to low pressure systems anywhere in nature without a container. So if you want to, grill for your mother on Mother's Day, make sure you get your propane in a container, because if you put it in your hands, by the time you get home, your mother's going to be very sad, right? It's not going to work out for you. So here's something I want to illustrate. Like, imagine if you could, okay, this is your three beliefs. Here's my three beliefs, hypothetically. Now, this isn't actually what I believe, but let's say I go high enough. I believe that you could see like unicorn nipples and Pegasus breasts. And then I believe that if you keep going higher, then you can see, green grass on the dark side of the moon, and that's what's causing the tides. Like those three claims are just as scientific and unfalsifiable as the claim of curvature, spinning, and the moon gravity thing and the vacuum thing. We can't verify any of that. So they're all on equal footing, scientifically speaking. They're not even really a scientific theory. It's more like a postulation that nobody can disprove. So when they say, well, you got to prove it, if it's your claim, you have to back up your claim. And then if you don't, they can just miss your claim without evidence. It's easily dismissible without any evidence. So all I'm trying to illustrate here is that anybody can go out and measure where the horizon should be and see if they can make observations that they shouldn't be able to see. All you need is an Earth curve calculator, binoculars, a mirror. I mean, these sort of things will get the job done. And I've been out there and I couldn't detect any curvature at 1 foot above water. I was standing in the water at the ocean. So I'm not asking you to take my word for it. I'm not asking you to do anything but to test it yourself, because it is falsifiable. It is something that you can actually prove. And when you ask globe earthers, they'll tell you to look at the sun, look at the moon, look at the stars, look at the shadows, right? They'll tell you to look at everything, look at a pendulum, all the stuff they tell you to look at, but they'll never actually tell you to go measure the Earth's surface. And I'm not talking about, the Earth is like completely flat, like a piece of paper. Of course, there's topography, right? That's why we measure over the water, because if the Earth is over 70% water, then you would expect it to be curving at 8 inches per mile squared. It would have to be, unless the Earth is 70% flat. Well, that's what we're measuring right now. We're measuring flat water all over the world. And this is what the argument boils down to. And this is where the nitty-gritty part is, so you should pay attention right here the most. So we see an object with the horizon further than 10 miles away at 1 foot observer's height. The horizon should be at 1.225 miles, but it's not. It's somewhere else. And we're saying that this is because it's about weather conditions. It's about how the eye works with perspective. It's about, how far you can see, because you can't see forever if you're in the atmosphere. You can't see forever, period, because you don't have, owl eyes. You have human eyes, and they're very limited, right? They're really good at detecting food or danger, within 100 yards. Not so good at 3 miles away, right? We can't really detect danger from 3 miles away with our eyeballs very good, because where in nature would we have danger 3 miles away, So when you look at this thing, you have to look at it like, why would the globe earthers tell you to measure the sun, moon, and stars? Why would they tell you to look at everything but the surface of the earth? But the flat earthers, the one that, the dumb ones, they're telling you to measure it directly. Now, if I were to go buy you like a new pair of custom boots, right? They're going to measure your feet, right? They're not going to go in there and measure your head, right? They're going to measure your feet directly. So that's what we're asking. All flat earthers are asking for is show us some curvature over the water, right? And what they do is they show us, partially blocked images or objects, right? And oftentimes they don't even know it, but that itself is still a black swan. And this is how the black swan works. If you have a woman that's 9 months pregnant, and she's pregnant with triplets, and she lays on her back, and the doctor says, "What color are your toenails?" She's going to say, "I don't know," right? So if she can see her toenails, then she's not 9 months pregnant with triplets. So with these observations that we're making, you guys keep showing us white swans and going, no, it's not a black swan, but it only takes one black swan to debunk all the other white swans. And you could show me 1 million white swans. If I got one black swan, then I've debunked you. That's how the black swan argument works. So if the Earth is a sphere with a radius of 3959 miles, then every observation must be, sorry, I forgot it, 1.225 times the square root of the observer's height in feet. So if the Earth doesn't have that radius, we can see too far, which we can, then it's not an Earth with a radius of 3959 miles. So what we're saying here is that we're testing it and it's failing. And this is the crux. This is where it's at. They say light is bending down at 8 inches per mile squared. So I don't know how you would verify that, Because light travels in a straight line until it reaches a different medium, right? So this is what refraction is. Light goes from atmosphere into water, right? You can see the straw bend in the glass, right? Now that's a big bend because that's a huge difference in density, the water and the atmosphere, huge difference. So what they're saying is light is bending down because of temperature. So the temperature would have to be getting colder and colder and colder and colder and colder and colder every mile for it to keep bending down like that. So if they want to prove that this is what's happening, they have to get a black swan observation, and they have to get people out there, like 10 people every couple of miles or whatever, and measure the temperature to prove that that's actually what's happening, because so far this is their just so story, right? We're seeing things we shouldn't be seeing in places we shouldn't be seeing them, way past the horizon. And they're saying the light is bending down around the curve. Well, they got to prove it. They can't just use a snapshot of the temperature of that day. They got to measure the water, the air, everything for 10 miles to prove that it's getting colder and colder and colder, causing the light to bend down, down, and down. Otherwise, light travels in a straight path like it normally does. Now, it does bend when it goes into glass, or there's from atmosphere to glass, or atmosphere to water, or water to glass. It does bend there, right? The light doesn't actually bend. What it does is it changes its angle of attack, right? So it's coming in at this angle, it hits a different medium, and the light slows down, and the angle changes. But then it goes in another straight line until it comes out of that medium. So light usually travels straight. It's not really bending. The light is just changing direction. So if they can prove that light is bending down at all these different angles because this temperature, now I don't really think that temperature does that. I don't think there would be any way for them to demonstrate this, but this is what they need to demonstrate at this point to explain why light is bending down. So I think I just about wrapped it up. So make sure you don't make like the same mistake of putting like a false cause on something. How do they know that's why the light's bending down, or that the light is even bending down, period? How do they even know that? They would have to be able to demonstrate it, and I don't think they can. So, Ronan, I'm going to go ahead and open it up for questions.
Thank you so much. So we are going to open it up for audience questions, but I'd just like to take the privilege to start by asking like a very short interview of maybe 2 or 3 questions, and then we'll go to the audience from that point on, if that's all right.
Yeah, sure.
So, Hank, for someone who is brand new to this, and obviously you just gave a ton of great information, right? But say you had someone who's brand new and you only had the chance to point out one flaw that they could intuitively grasp with the heliocentric model that would make it clear to them that they should look into it further. What would you choose at all the different things you've researched to be that one introductory wedge to get someone to look into this?
Well, I would say the surface of the water, right? But a lot of people are going to say that that's so dumb that they're not even going to entertain it. So let me give you something that you can entertain. Imagine you have all the matter in the universe in one spot before the Big Bang, plus 95% of the universe that you can't see or observe, which they need for their model to work, which is the dark matter and dark energy. So everything you can see, plus everything we can't see in one spot, that would be a pretty deep gravitational well, wouldn't it? If mass attracts mass and this causes the bending and warping of space-time, or whatever kind of gravity they choose, that would be a pretty deep gravitational well with a hell of a lot of pull, wouldn't it? How could anything escape that gravitational pull?
Right. Well, thank you, Hank. So there's a lot of people here. So let's open it up for questions. Does anyone have a question that comes immediately to mind for Hank? And again, obviously, always being respectful is the name of the game. But does anyone have a question? I have plenty more, but I want to give everyone a fair chance.
Yeah, I got a question. Hank, when it comes to the flat Earth theory, the most striking situation about it is the fact that the UN made over 123 countries signed a treaty, the Antarctica Treaty, and preventing people from going to Antarctica. I've seen flat Earth model, and most of the models states that the Antarctica is basically the edge of the flat Earth, and it makes me curious why the UN made over 123 countries sign that treaty, and it kind of boggles my mind the more I think about it.
Well, the flat Earth isn't a theory. We all observe a natural stationary plane of existence. I don't think anyone here can say that they've experienced curvature or axial rotation, right? So it's not a theory. It's what we all experience. It's what your senses are telling you. So I would say if you believe flat Earth is a theory, what secondary knowledge has convinced you that your primary knowledge that you receive from your own senses is lying to you? So, and another thing, it's not a model either. A model is like a toy, right? It's like, this is what we think is going on. This is what we're going to use to make predictions off of, and they may or may not benefit us in technology and other aspects. But a model isn't reality, right? The dirt between your toes is the reality. And I would just say that the whole UN thing, I think it's a lot like Iceland. They told the Norsemen told the rest of Europe that it was Iceland. So they said tundra, basically, in modern English, right? They said, oh, it's just tundra. You wouldn't want to go there. You wouldn't want to live there, right? Because it turns out that they were ethnocentric and didn't like foreigners. Imagine that. So I think that's what's going on down below, right? They say that down south, it's all tundra. Well, wouldn't it, if Yeti crab can exist, right? And these are just crabs that can live in the deepest, darkest part of the ocean near these geothermal vents. Wouldn't it be possible with these geothermal vents to irrigate that thermal energy and maybe make even places that were livable if they did it correctly? So I think that it's just hidden land. That's what I think it boils down to. Hidden land.
Thank you. If I could ask another question, with the advance of technology that we've had, right, all the different technology like drones and rockets and videos and cameras and so forth, is there anything that's come out in recent times that is sort of like new visual evidence that helps to prove either that the Earth is flat or to debunk the globe or anything like that? Like, is there anything that's come out new as a result of technology that flat Earth has been able to show?
Well, yeah, it's not actually a new technology. It's the sextant. It's actually a very old and ancient technology, and we're understanding that it has to be a triangle, right? When you're triangulating something, it has to be a triangle, or it doesn't work, right? So if you're trying to get your position here on Earth, right, and the light is bending down at 8 inches per mile squared, then it's not going to be a perfect 90 degrees at that angle, right? It's going to be some more acute angle, and you wouldn't be able to get they wouldn't work. The sextant it wouldn't work. Now, there's a big misunderstanding. A lot of people think that you have to go up to measure the curvature, but why would you have to leave the Earth, the thing you're trying to, measure, to measure it? You're right here on the surface. Wouldn't it just make a lot of sense to measure it here directly? And because of topography, that's too many variables for the average person who isn't like a mathematician. So we say do it over water, because anybody is smart enough. It doesn't matter who you are. You're smart enough to plug in the numbers in the Earth curve calculator and decide for yourself whether it's flat or it's curved. And that's all we're asking people to do.
Does anyone else have a question or comment? So Hank, you also believe in the firmament? Is that a necessary component in your thinking as well? The solid or semi-solid dome over the planet as well?
Well, we don't know the shape of it, but a lot of us think that it's a firmament, dome-shaped. Some of us think that it's a flat top, flat ceiling. And because of this, think about how perspective works. Let's say you have a drone, right? And you lift off and you stand on the liftoff pad. It's going to be right over your head at the zenith position, 12 o'clock, right? And you start, let's say it's a really good drone. Okay. So you start going west and it gets lower and lower and lower and lower till it kind of disappears into the horizon, but the altitude of the drone isn't changing. It's still, right under that 400-foot ceiling that they give us here in America. And it's still at the same altitude, but it appears to get lower, right? And then let's say that, once it leaves, you can't see it no more. This would be illegal to do. This is not advice. But let's say you could circle back around and come back around from the east. It would appear to rise like the sun, even though it never left that 400-foot altitude ceiling. It's never getting lower. It only appears to get lower. And that's why the sextant thing works so well, I think, is because anywhere in the world, if you know what time it is and where the star's location should be, you can almost pinpoint your exact location on this Earth. And the stars, they don't change. The position of the stars, they never change. Only the wandering stars, the so-called planets, those are the only ones that change. Right, all the other stars have the exact same position for 32,500 years, according to the BBC and the oldest known star chart that they found.
So what do you consider planets to be? Are they flat as well? Are they there? Are they like, do they have a spherical shape? What are planets to you? The wandering stars that you mentioned.
So to me, it's a light in the sky. And what it's made out of, what it's doing, how much it weighs, what's the mass, I don't know. It appears to make certain patterns in the sky at the exact same time that you would expect it over and over again so well that we can predict where it's going to be for thousands of years in the future. Now, that doesn't sound like a result of a random Big Bang. That sounds more like a Swiss, watch, a timepiece. One of those really high-end, really ornately designed watches. That doesn't sound random at all. So what are the planets? The honesty is we don't know, but they're more dependable than anything else we've ever seen.
So whenever there's like a meteor, right, like something that comes from the heavens or comes from outside of the Earth, and it breaks through our atmosphere, and then it hits the Earth, how is that possible with a firmament dome?
I would say you'd have to show me, because when they've dug and tried to get the iron from these so-called meteorites, they can't never get it. It's like they dig and they don't find anything. They don't find the iron they were looking for, they were hoping to get, and they wasted a lot of money trying to do that. So I would say, because you see a streaking light in the sky, right? How do you know that it's made of ice and metal and all these other, known elements? When you see a light, why don't you assume that it's like all other lights, right? And all other lights in nature is plasma. Fire is plasma, right? Lightning is plasma.
Well, I know I have seen some in museums and stuff, right? And others are sold for huge amounts of money.
Well, you can also buy Martian real estate. I hope you don't, but
This is true.
so how do you verify that's from some other place? Do you know what other places are made out of? And if they're made out of the same material that we have here, then how can I verify this rock has been to this place that is supposed to exist out in a vacuum, where there's these gas balls like Jupiter, where all the gas doesn't, do what it normally does and fill the available volume. It's just sitting there in like a big pile, right, of gas that's in a perfect sphere, and it's not doing what it should always do. So I've recently come up with this understanding of the second law of thermodynamics. And this is basically the gist of it. Entropy, right? Hot always goes to cold. So if you got a cup of coffee, you get a phone call, you come back 30 minutes later, it's all the temperature is leaked out and it's reached equilibrium. So it can't get any colder because it's in equilibrium. So the same thing with a charge. If you have two car batteries, one's completely charged and one's completely dead, you hook them up with the cables, 24 hours later, all the high charge is going to move into the low charge until it reaches equilibrium. Then you're going to have two halfway charged batteries. So the gas pressure works the same way. If you have a propane tank with 250 psi, despite all the gravity and bending and warping of space-time and mass attracting mass, I'll give you all of that, it still doesn't contain it. Once I open that propane tank, even though it's facing up away from the pull of gravity, at the surface of the Earth where it's only stronger in the middle of the Earth, but we can't get there. So this is the strongest source of gravity. It's going to spew out until it reaches equilibrium, and you come back 5 or 10 minutes later, and it's going to be 14.7 psi at sea level. Well, I'm going one step further, right? So this is specific gravity. Anybody can look it up. Specific gravity is the only gravity that is actually testable by the scientific method. So let's say you got a pail, right? And you put an apple in it, right? So you pour water in the pail, the apple rises. You take away the pail. You take away the water, and the apple sinks to the bottom. Well, what did you manipulate? The cause, right? So what is the cause in this case? The relative density of the object. That's what I manipulated. And what was the effect? The effect was I proved that if you manipulate the relative density of an object, this is why objects here on Earth go up and down, except for birds and aerodynamics. Every other object in a medium is going to reach its equilibrium, and then it's going to stop. So if you drop a feather and a bowling ball in a vacuum, they're going to go at the same speed until they reach their equilibrium, right? Now, if you do it in an atmosphere, let's say you do it above the Kármán line where there's no atmosphere, allegedly, right? And you drop the bowling ball, it's going to go down really fast, and so is the feather. And then as the atmosphere starts to increase the pressure, right, it's going to reach terminal velocity, which means it can't fall any faster. So that 9.8 meters a second, yes, that happens. Thank you. But it doesn't always happen. And yes, when you drop things, sometimes they fall, but they don't always fall. For example, a anvil will float in mercury. I know it sounds crazy, but we can show you the GIF that you put anvil anywhere on Earth, it's going to fall down, except in mercury. It floats like an ice cube because the relative density is more powerful than any gravity you can throw at it. And they say gravity, well, that's just one definition of gravity, right? So there's Newtonian, there's Einsteinian, there's dark gravity, and then there's specific gravity. So this specific gravity is the one that you can test. It's repeatable, falsifiable, testable. No matter what object you have, if it's in a medium, it'll seek its equilibrium. And think about the water cycle. The water changes phase, it turns into a gas, it goes straight up. I mean, defying gravity. And then people say that you have to have gravity in specific gravity. It's like, no, you can't mix the two. You can't hijack on that word. You can't just get on the gravity train and say this proves the bending and warping of space-time, because the bending and warping of space-time is just a concept. Like, I'm a Texan, so I have this concept about liberty and freedom, right? And governing myself. Like, you can't take those away and bend them. You can't bend my liberty because it's just a concept, right?
How does the concept of gravity, or what you were just explaining, prove that the Earth is flat?
It doesn't. What it does is it illustrates that not every gravity is scientific. There's only one scientific gravity, and that's specific gravity. It's one that you can test and falsify. So if I tell you that iron floats in mercury, this is a test you can do, right? If you tell me that a massive object will cause the bending and warping of space-time, the bending and warping of space-time that happens in space as well, right? So in this near perfect vacuum where there's no material, there's this bending and warping of this non-material, non-physical space-time, right? So it's metaphysical. It's like talking about God and angels. Like I can't test it. I can't prove it. I can't put it in a jar and take it to the lab. I can't paint it yellow and see what it does. This whole bending and warping of space-time, it's not scientific. Einstein had no hypothesis in his paper in 1915. It was all mathematical and equations and stuff. So math isn't science. Go ahead.
I was just wondering if, with the Earth being flat, what's underneath? Like
the Russian borehole, they dug almost 8 miles, and every step of the way they predicted what they were going to find, and they were wrong every time. And when they got to 8 miles, they couldn't dig any further. So we don't know. And that's the thing about flat earthers. If you talk to a real flat earther, we're all hyper empiricists. If you ask us something we don't know, we better say we don't know, or else you better cite some sources to back up your claim. We're never going to go into speculation unless we say, hey, I'm speculating, what if the sun causes the tides because it has more energy and it would, disrupt the material. Yeah, let me think of a better way to phrase that. It would, and this is, hypothetical. This is just an example. Let's say it would perturb the water molecules and cause the tides. Right? That's just a speculation. So I don't have anything to back that up. So don't hold me to it. That's what we say when we're speculating. Any other time we're talking and you ask us to cite our source, we're going to be more than happy to stop what we're doing and cite our source and back up our claims.
That makes sense.
Question, if I can.
Okay.
Sure.
Okay.
You wanted to say following from that first?
Yeah, I had a couple more questions, but I can wait until after.
Okay, well, if you want to ask a few, go ahead.
Well, yeah. Okay, so first question, on top of all those, were you raised thinking the Earth was flat or as a globe?
Absolutely not. I grew up in Texas, and we have a regular public school system. But when I was in the first grade, I discovered the science books on the bottom labeled space. And my grandmother's sister, my great aunt, she was the head librarian at the public library. So I kind of had free reign with all the space books that I could consume. And I was so into it that I debunked the moon landing before ever hearing someone else say that it was fake. So when I saw the flag waving in the wind, I knew there was no wind on the surface because before 2019, the moon was in outer space and it was considered a vacuum. After 2019, now they say that the moon is in Earth's atmosphere, according to space.com. But yeah, I was raised globe earther, grew up watching Star Trek, Star Wars, space video games, etc., etc., etc. But I was following it so close that I started seeing problems. And there definitely is problems, specifically when you try to reconcile Einstein's gravity with quantum physics. There's this thing called the cosmological constant crisis, or the cosmological constant problem, right? And this says that when you compare what we theorize compared to what we observe, you're off by an incredible 120 orders of magnitude. This is the huge factor, according to Michio Kaku. He said, if you're off by a factor of 2 or 10, oh man, you need a new theory. Right, but they don't do away with the theory. They just keep ad hocing explanations where they make up on the spot as to this is why this still works. Now, any village idiot can tell you why it still works. So, according to Michio Kaku, the galaxies are spinning 10 times too fast, and there's not enough gravitation to create enough pull for the outer stars because it's the opposite of a solar system. Pluto has the longest year and Mercury has the shortest. Well, in a galaxy, it's the opposite. The stars near the center have the longest year, and the stars in the outward arms have the shortest year. So it's like taking kids and put them on a merry-go-round and see what speed they fly off, and then increase it by 10 for your next experiment, and pray to dark matter that it's going to come save the children and that none of them get hurt. Right, that's what's going on. The math doesn't work out at the galactic level. Now, as far as making so-called predictions, which are actually postdictions, because it's a pattern, the sky is like a clock, like a pattern. They say they're making predictions, but they're all postdictions. But the math works out at the solar system level, but it absolutely doesn't work out at the quantum level, like I said earlier, quantum physics, and it doesn't work out at the galactic level, and that's why they need the dark matter theory, because it doesn't work.
So when you realized at one point in time in your life that the Earth is actually flat, it's not what you were being taught in school or what everyone around you thought, did you find that you were talking to everybody, trying to get them to see that that was the case, and then maybe be ostracized by people or ridiculed by people? And if so, how did that affect your life?
Well, the thing is that I'm backing up what I'm claiming, right? I'm telling people to go do it themselves. So when I tell people, let's say 10 years ago, I told my uncle, yeah, man, look into that 9/11, that building 7. He's like, oh, you're crazy, you're a conspiracy theorist. And then a couple years later, he'd come around and be like, you know what? You were right. I'd be like, what was I right about? What are you talking about? He'd be like, about, building 7, about how it collapsed. And then a few years later, September the 3rd, I think, a few years back, Fairbanks, Alaska, did a 4-year study with another college professor from Japan. And this college, it's a structural engineering college. And they nearly quoted me word for word. So this is what the abstract says. The abstract says that in Building 7, it was a near simultaneous collapse of all the columns. Now, a column is what holds the building up, right? So if it was a fire, it would have been a progressive collapse, like dominoes, because the fire doesn't poof the whole building up at once. Only some sort of explosion or timed demolition could do something like that. A fire isn't capable of doing that. So in Fairbanks, Alaska, when they put their stuff out, I could just grab that link and just post it wherever, and I don't have to say anything. Nobody has to believe me, because this is now what the experts are saying. So if anybody ever ostracized me, that's their problem, not mine, because I can look at both sides of the coin on every situation and weigh out the evidence like a sober judge, instead of getting my emotions involved. And then, you got your preconceived bias, you got logical fallacies. Once you understand all these things and you know how to govern your own emotions, then you can look at things more clearly rather than having the cognitive dissonance. Now, the people with the cognitive dissonance, that's their problem. That's something that they have to work through, right? And if they treat me different while they're going through that, I don't really care.
Well said. Thank you.
If I can ask you a question now. So postulating, you said that there's a firmament, whether it be a dome or a ceiling type of firmament. Do you believe, like as the Bible says, that above that firmament is water, that there is perhaps outside of that or above us a watery layer or water beyond the firmament? Is that part of your understanding?
So this is the law of correspondence. It's a natural law. As above, so below. So they say that there's water above, and so there's water below, right? So we know that there's deep underground oceans, right? North Texas, the Panhandle, is connected to one of the largest. They found a whole bunch of them in China, right? So we know that there's water below, and if there's evaporated water above us, then it has to be above us. But when you're talking about on the other side of the firmament, I mean, who could know such things? We could speculate that, there is a firmament, but there has to be a container, because you're breathing right now. So if you got gas pressure, the necessary antecedent for gas pressure is containment. So there has to be something. It's like you can't eat a steak without cow. So nobody's eating a steak and wondering whether or not cows really exist or not. So yeah, there's something up there, but who knows what's above it, or who knows what it's made out of.
So a follow-up question to that: do you believe that the Earth's moon, the moon that's visible from Earth, is inside of the firmament, or is it in here with us, or is it on the other side, or is it part of the firmament?
I would say it's hard to tell the location of the moon. They say that it's 238 miles away. 238,000 miles away, but we can allegedly see a piece of it that's like 50 miles across with our naked eye. So when you do the math, that doesn't really work out. So we don't know where it is. We just don't think that it's as far away as they say that it is. And we don't know that it's made out of, I mean, who knows what it's made out of? The astronauts gave petrified wood to, I think, Holland, and passed it off as a moon rock. So we don't know what it's made out of.
Question. If I assume that under the model of flat Earth that you're describing, the South Pole is, not actually some singular point, but spread around in, a circular fashion, where the North Pole is, in fact, more of a representative focal point, correct?
So we don't have a model. Anyone that ever tells you that we have a model, it's incorrect, because at this point we're consolidating facts, right? So we're not free enough to create a model. And the truth is, you don't have a model either. You don't have a scientific model. In fact, your model doesn't work either. So just to be clear, if you've seen concepts of a flat Earth, it's like a disk flying through space, or turtles or something involved, We're not claiming that. Nobody claims a model. If you're claiming a model and you're a flat earther, you're obviously new and you don't know what you're talking about, because what people do is they put out these models that are straw man versions of what we're claiming that we live on, and then they debunk the model. And then they say, oh, this is fact checked. We debunked this. Well, you debunked a straw man. Classic. I mean, so there is no model. Now, I've seen the concept that you're referring to, right? That's not what I'm claiming. What I'm claiming is that you can measure water and it's missing curvature.
Isn't that a bit of a double standard, though? Because you're effectively trying to debunk other models while simultaneously not presenting any to be tested.
Okay, you want a model? I'll give you a model. The water has zero curvature. Go test that. I mean, if you don't mind.
Well, if the Earth is flat in any configuration, then I should not be able to fly around from any point to any other point without crossing over any sort of central place, wherever the center of that flat space is. You know, it would, if it's round, it's wrapped around itself, and I can go without crossing over a path I've already been. Places would be connected two different ways, effectively, in either direction. And so the easiest way for an individual in their own life experience to then test things, you know, would be either to charter a boat or a private series of private planes or so on and so forth, to fly or sail from point to point and see what was actually closer to what, and if they could get something from multiple ways to see if, you know, it was wrapped around. This is something you could do in your own individual life, correct?
Yeah, you're talking about making a map. Like, we're not trying to prove where the continents are as a relationship to other continents, because all maps are incorrect slightly somewhere. There's no perfect map of the world, right? And what is going on is we have Cartesian coordinates maps. They're all in grids, right? Squares. If the Earth was a sphere, wouldn't the maps be wouldn't they be rectangular coordinates? You know, because rectangles fit on a sphere, right? But they're all flat Earth maps because they're Cartesian coordinates. So if you want to know the shape of the Earth, yeah, you can fly around and go to space or whatever you want to do, but I don't know. I just think that you should measure it directly. I don't know why that makes sense, but like if I wanted to prove to you that I had a 12-foot boot size, wouldn't I just give you my foot instead of, well, you can measure my fingernails, or, you know, you can take a train, right, and ask other people, right, how big my foot is. No, I would give you my foot and say, see, it's a size 12, told you. You just measure it directly. I don't know why everybody comes up with, we could go to Antarctica and we could take flight and we could take rockets and we can go to space. You're not going to space, sorry, but you can go to the ocean. 95% of the population lives near an ocean.
Well, the thing that I am suggesting, it would involve simply chartering boats. You know, you could do this if you had an ocean-worthy vessel. Like I'm not giving you know, saying go become an astronaut. I'm simply putting out the thought process of being able to test if the surface of the Earth is wrapped in some way. Now, you could say that, you know, potentially you could have a cylinder, and that would also be wrapped. But the notion of whether it's wrapped, so you could come from either direction to a similar point in all spaces, that is a testable hypothesis. An individual with a boat could do. They wouldn't have to make any measurements. They would just have to say, can I get from here to here without crossing this? Do you understand what I don't know if I'm wondering if I'm communicating clearly is what I mean to say.
Well, if what you're saying is true, then you should be able to go to Argentina, South America, and take a short flight across the ocean to South Africa or Australia or New Zealand. But what you'll see is most of the flights, they go towards the north, and then they come back down towards the south. Now, it doesn't make sense that there wouldn't be like direct flights. And if there are, I would say that book it, see if you can go on it. So I'm not completely disagreeing with you. But what I'm trying to illustrate is that what's that going to prove? Okay, we don't know how fast they're going up there, right? Nobody has like a speedometer that they could take with them. And you're going to be a lot better off just by measuring it directly, because at 10 miles, there should be 66 feet of curvature. So when I was in North Beach, I mean, me and my wife at night saw the lights across the way. And it's like, those light poles aren't 66 feet above the water, right? So anybody can do this. You don't have to take my word for anything. I'm just an egghead on the internet, right? Who knows, right? I may be lying. But all I'm asking people to do is just go measure it for themselves and find out. If it's curved, it should be easy to prove it, real easy, because you can't see past a certain point, and it's going to be like that every single time. And you're never going to be able to see further. But the problem is we keep seeing further than we're supposed to be able to see, and we've debunked horizon, and now everybody admits that it's a refracted horizon. That's what the flat earthers have been saying.
Well, the comment you made earlier about refraction, you were talking about light coming down through the atmosphere, but the light coming across the atmosphere is different, because the light that comes, conceivably from space, according to a globe model, passes through the atmosphere directly and comes down. Whereas light that is coming, through the edge of the curve that you're looking at, would be passing through larger amount of atmosphere, because it would actually be going across in that way, and so it would experience a greater amount of, it would refract more so because it's going through a much larger amount of atmosphere, because it's coming through sideways at a much more a much higher angle. Okay,
so if you got a star right over your head, it's not passing through a bunch of different layers at an angle, right? But if you got a star that's, say, like between 30 and 60 degrees, right, that's going through a bunch of different density layers, and you would actually see more refraction in stellar objects than you would looking across the same medium, because if you're 1 foot above the water and you look across 10 miles away at 1 foot above the water, you're in the same exact medium, the same density. Now, if something is several stories high, the higher up you look at the building, yeah, it might get wonky up there, because now you're looking through different layers of atmosphere. The higher you look up at a building, you're not supposed to see it, and you see it, and you look up, it's kind of wonky and wavy up there up top. That's because you're looking through different layers now. But if you just look at the bottom of the image, that's going to be clear, except for, okay, this is really important to understand. What you know about light is very little. Me too, right? I'm in the same boat with you. Light is incredibly hard, difficult, not easy to understand. So when you're looking at Chicago from Michigan, right, at like 50, 60 miles away, you're not actually seeing the buildings. You're seeing the light reflect off the buildings. So as the light is reflecting off the buildings and headed towards your eye, it's expanding in all directions. It's diverging. The image is stretching like you're zooming in. And you can see this when you're at the bottom of the pool and you look across and you see a light on the other side at nighttime. And the light looks huge, right? But then you get close and you change the bulb, and it's actually a very small, tiny little filament. But the way that light works, it expands in all directions. And if you look at the inverse square law, every time you double the distance, the light intensity drops 4 times. So the intensity is what changes. Light does travel forever, but not at the same intensity. So I guess it could never go down to 0, because it's always going to be a fraction of a fraction of a fraction. So when you're looking at light from that far away, it's like, say you got a cowboy and you want to read his belt buckle to see which rodeo he won or whatever, right? As you zoom in, his feet are going to get cut off on the bottom. Well, the same thing's happening to the image of Chicago. The light is diverging in all directions and stretching, and one of those directions is down towards the water. And when the light bounces off the water, it never hits you in the eye. So this could cause false horizons. And anybody can look up Skunk Bay time lapse with grids and see what I'm talking about. You can see that as the day progresses, there's a GIF. I'm sure somebody's posting a GIF right now. And you can see how it looks like the other side of the bay is getting flooded out as the day progresses and the sun perturbs the atmosphere, but it's not. It's just the light, with the way it's interacting with the atmosphere, it's causing a false horizon in front of it when the actual real horizon is actually behind it. And you can see it. It's clear as day to see the false horizon come up, swallow the buildings, and at the end of the day spit it back out like it never really happened. But it's really difficult to see this sort of refraction happening where you can notice it, because when we're looking at refraction, it normally takes instruments, right? So in this case, we took a time lapse and we sped it up. Now you can see it, right? But what really happens is that the horizon changes places throughout the day based on interference of the conditions of the atmosphere and the sun interacting with it. Sorry if I went on a rabbit trail on that one, but it's very difficult to understand what light is doing.
I followed what you were saying. I disagree with a little bit of it, but one of the larger points is I don't understand how many of the points you're making actually relate to the differences between a globe or flat model of the Earth. Like, for example, you're pointing out many flaws in, institutional sciences and what they pretend to know, what they don't really know. I mean, they've changed what they think the speed of light is on occasion, things like that. And these are true. Fair enough. But there's a difference between, okay, they're wrong about some things, or they don't always admit when they're wrong about some things, and therefore flat Earth. I guess I'm just not following how a flat Earth. It seems like you are looking for things which can't be explained, and then therefore, if not everything can be explained, the Earth is flat. And I'm being critical, but I'm being bluntly honest.
Yeah, I just want to say that, that's not my argument. My argument is go measure the water yourself and falsify or verify it. That's actually my argument. That's my real argument is here today. Everything else about a model, we don't have a model. We don't live in a model. The Earth is the real Earth that's outside. When you go walk around and you get dirt between your toes. That's what the real Earth is. And it presents itself as a flat, stationary plane. And you can all go outside and verify this. So the whole model thing, we don't have that. We're not worried about models. We're not free enough as a population to go test this world and its boundaries and see what it is and what shape it is and what it's doing and where the boundaries are. As far as I know, we have these mandates from governments saying that we can't go to Antarctica and we can't tell what it is. So all we got is what's right here, right? And this is the real Earth, and you can actually go test it and see what it is. Now, as far as the other stuff that I've talked about, gravity is important, right? Because how are spaceballs made? In the heliocentric model, gravity pulls the matter together because mass attracts mass. So if I debunk mass attracting mass, which I don't need to do that, Professor Shankar has already done that for me, professor of physics of Yale. And, I can cite my sources for that and show you that mass attracting mass, that's 106 years out of date, pseudoscience. And then the whole bending and warping of space-time, yeah, you can't prove it. So I can just dismiss it because there's no hypothesis test or experiment that we can demonstrate the bending and warping of space-time. So, yeah, all I'm trying to do is let you know that the real shit, sorry for cursing, is the specific gravity. And you can test it with balloons. I mean, all children, like to play with balloons because, this is what the real world is, right? Not everything falls when you drop it. Yeah, you drop your cell phone, it's going to break. Did you expect the atmosphere to hold it up? No, there's not enough buoyant force in the atmosphere to hold up your cell phone. But there is enough buoyant force to hold up the balloon.
So I know you'll say, we don't know and we can't know, but is space travel just out of the picture? Should we not even be bothering? Is that a pipe dream? The whole concept of exploring beyond this realm, do you think?
Well, it's kind of funny because what do you mean by space, right? You're in Canada, I'm in Texas. So there's a great deal of space between us, right? Yeah, we can travel, right? You could come to Texas and I could show you the Gulf, right? But as far as us going to live on Mars one day, I mean, that just seems bizarre to me to think that you could go live on a light in the sky. I would think it would make a lot more sense that, we could go terraform Antarctica. Doesn't that make more sense?
Perhaps, yeah, quite possibly. Do you think that the nature of the Earth as we observe it is explicitly indicating an intelligent designer, like a creator? Like, does that go hand in hand with this understanding that this is some kind of a created realm?
Well, to me, it does, because when I think about what Native American life was like, and the man would just go out early in the morning and just get, fruits and berries and fish and deer from, everything we need is here. It's almost like an ant house for humans, right? And then when you look at the information theory, right, and this is the part that you need to type in, functional sequence specified complexity. When you look into that, I mean, you'd have to have a great deal of faith to find a Rolex watch in the woods and think to yourself, my God, how long did it take for the woods to create this magnificent, timekeeping device? That would require some wow faith that I do not possess. So when I see something with intricate design, specifically functional sequence, right? That's what the DNA pattern is, whatever you want to call it, the code. It's a functional sequence with specified complexity. So we know the difference between a sand dune and a sand castle. Everyone on Earth, every child on Earth knows that the sandcastle has to have had a creator. You're never going to get a letter from the mail from no one, right? If you trace it back, it's always going to go back to the three things that information exchange requires: an intelligent sender, an agreed upon medium, like English, and an intelligent receiver. So if you send an English letter to a man who only speaks Mandarin, no information was exchanged. All three requirements have to happen. And the only way that could happen is with an intelligent sender. So yes, I would agree that this place is special. You are special. You're not mold on bread. You don't need to die. We do need to take a better care of our sacred rivers, water, soil, air, right? I'm not, completely down for destroying the earth, but I think that the climate change thing has been hijacked by people who want to tax the West. I mean, why wouldn't they want to worry about China, right? They got companies over there that produce more pollution than entire countries. But yeah, let's tax the West because that's going to solve all the problems, right?
I see. And you mentioned Antarctica, and you may have mentioned this before, but do you believe, like I've heard some people say that maybe our little ice wall enclosed part of this world is just one of many scattered throughout a wider ice plane, or that there could be other realms beyond the ice wall, but on the same plane? Do you subscribe to that concept?
No, those are called outer ponders. Although I have a few friends who are outer ponders, we don't all agree on all the speculative stuff. But these outer ponders, it does make sense that there could be, hypothetically, other people from other continents that we're unaware of. Whether they're in another container, I mean, that's all speculation. So I couldn't really, definitively say what's going on, but there are a sect of flat earthers that are called outer ponders, that they believe that there's maybe more land outside of this container that we're in. And maybe they don't even believe in a container, some of them. But yeah, most flat earthers, we all agree the water is measuring flat. Like, we all disagree on a great deal of many other things, but we're not really at each other's throat. We just say, okay, you and I, we're not going to agree on the subject. So we're going to agree to disagree, bury the conversation. We're never going to talk about this again because we're not going to change each other's minds. So let's stand on common ground. And that's what we're doing. That's why we all get along, is because we have common ground.
That common ground always includes that the Earth is motionless. Is that correct?
Yeah, I don't know of any true flat earthers who think we're flying through space upward at 9.8 meters a second squared, which is really important to understand. Vladimir Lenin said the best way to control the opposition is to lead it ourselves. So why is there a controlled opposition known as the Flat Earth Society? They say all the wrong things to make us look like idiots, and none of us are society members. I've never met one in 6 years. I think I'm getting to 6.5 years now. Yeah, that's all globe earthers making it look bad, because we're being censored. If you know about Truth, or Veritas, they had was released by a Google whistleblower, and flat Earth was one of the things on this Google blacklist. So if you'll notice, when you search flat Earth, you're going to get 100 debunk videos, and you might find one or two videos actually made by flat earthers. And this was a request of the government asking the alphabet agencies like Google, Facebook, and YouTube, like, hey, what are you going to do with all this flat Earth stuff and all this right? So now on everything that's flat Earth related, you're going to see that it's an archaic theory about what people used to think the Earth was like. Yeah, like back during the Egyptians lived and we could build buildings that lasted for thousands of years into the future, people thought the Earth was... Yeah, that's an archaic theory, but guess what? 2,000 years ago, apparently there were some Greeks back before archaic times who thought the Earth was round. So you guys have a model, just like we do. We don't have a model. And you guys have an archaic thought on what the Earth is. I mean, think about it, guys. If you're a heliocentrist, Helios, well, that's the sun god, and Apollo is the guy from Revelation, Apollyon, right, who comes out of the bottomless pit. And, you know, all this stuff like Jack Parsons, he was a known occultist, and he was like with Aleister Crowley and L. Ron Hubbard, and they were all hanging out back in the day. And it's like the NASA was started by Nazis. So Werner von Braun, like, is a Nazi guy, and you know, other Nazis got tried and, you know, hung, but these guys got to lead like NASA programs and all this other stuff, and the planets are named all these pagan gods. I mean, obviously, it's the Big Bang as a creation. There's no science involved. The first step of the scientific method is to observe natural phenomena. Nobody observed the Big Bang. So if it can't even pass the first step of the scientific method, how can we prove that this static that everybody sees on their tube TVs from the 80s, 1% of that actually comes from the cosmic background radiation? How do we prove that's from the Big Bang? How could you possibly prove that? How could you prove that they're directly related unless you could manipulate the Big Bang, which is the cause, and see the cosmic background radiation as the effect? You can't do it. It's not science. There's no science in cosmology, astronomy, theoretical astrophysics, paleontology. There's no science involved. It's not natural science, to be specific.
Does anyone else have a question or comment for Hank Hill, or in general? Will you have the chance?
I have a question.
Go ahead, my friend.
Hey, Hank, it's Matthew. So how do GPSs work in the middle of the ocean? And then also all those big, you know, those big 6-foot diameter satellite dishes that we've seen since the 80s and 90s before we had the small ones. What were they pointing out in the 80s and 90s?
Well, it looks like 45 degrees from what I could tell. Yep.
Depends on your latitude, right?
Right. Okay. So they appear to be pointing like halfway between the sky and the earth. Right. So if you were to see, what people don't realize, that the underground marine cables, it's like over 90% of our communication, right, is these submarine cables that go from continent to continent, right? Because radio signals, anybody who owns a cell phone, they know that the light doesn't travel forever. So you go outside to take out your trash, you start losing the Wi-Fi signal. You go down the block and you've lost connection completely, right? This is because of the inverse square law. So these communications like this, they're not very good. They're not very good over long distances and weather patterns and stuff like that. So the best way to do it was, you know, the cheapest way is to send it from the ground, right? And, you know, it's interesting because you got projects like Google Loon, where Google is going to put Loon satellites so that they could get, you know, internet to rural places. And then you got America came out and admitted that parts of the government were putting out balloons to surveillance the American population. And it's like, why would they need balloons if they got 3,000 satellites up there? I mean, they should be able to see like everything we're doing. You know, we should get like live feeds. And, you know, back in the 90s, they would just like zoom in on nude beaches and show you that this is what they're doing with their satellites. But I don't think we can verify any of that stuff can actually be done. So where does the source come from? I don't know, but it sure would be expensive to send it to space just to send it to Earth when we're on Earth and we could just send it across with cables. And there are wireless communications happening, but they're just not as good or as cheap.
Like the whole thing, we went to the moon and they made a phone call to the president, but we can't fucking make a phone call in Walmart by the milk section.
Yeah, my wife, she's all about the moon being fake. But yeah, if I can't get good signal, and anybody who knows me knows that I can barely get good signal while I'm at work. Like, how come I can't get good signal, but they can live stream from the moon in 1972 when the LIM took off in 1972? You can actually see the LIM taking off, and they say that that was a robot camera that just happened to take off, lift its lens at the exact same time that it took off. Like, but I can't get like good signal, on the interstate. Come on.
So there were balloons in the 80s that were stationary, so the satellite dishes never had to point somewhere different. And then there are satellite dishes on the equator that point straight up, or are those fake?
I'm not saying satellite dishes are fake, right? I'm just saying that it doesn't have to go all the way to space, right? We could put balloons up if you need to, get over a great distance, right? But a lot of people talk about you can bounce light off the moon. You can bounce radio signals off the ionosphere. So I really see, no real point in having to send up, a rocket into outer space for us to have signals with each other. We're here on Earth, right? So NASA, I think their budget for helium is like the highest in the world. So what do they need all that helium for? I understand specific gravity better than you do.
So, Hank, for those of us like myself who can't do math and don't have instruments of any kind, what are some of the ways, and you've probably covered this already, but just some of the ways that people can use their own senses and their own intuition to start piecing this together for themselves? And maybe,
First of all, a lot of people, the Earth. Oh, sorry, I thought you were done.
Yeah, I am sorry. Go ahead.
First of all, people say that the globe is common sense. And which senses are you talking about when you say that it's common sense? Because can you see curvature? Can you experience motion? Well, they say you wouldn't be able to feel it. Right? So I would say, common sense, number one. What does water do when you pour it out? It seeks equilibrium. Right? Like every time, no matter what. And it's the physics of water. It's very easy to understand that it would be level. That's why we call it sea level. And that's why I'm telling you that you can go out with a mirror, right? Like a dressing room sized mirror, put it in the water and face the sunset or the sunrise and have the other person on a lake, right, a body of water, and have them see if they can see the reflection, or get a spotlight and see if they can see yours when the sun goes down. Right? You can test it very easily because at 10 miles, there'll be 66 feet of curvature. Now think about this. Say I got a 6-story building, right? And there's a deer on the other side of the building. Now I can't shoot the deer with my camera or my rifle because I can't see it. Right? It's a 6-story building. It's blocking, right? That's what kind of bulge of water is going to be between you and the other person at the lake. It's going to be a 6-story building of water. Now, if you're claiming that you can shoot that deer with your rifle due to refraction, I'd like to see that, because I don't believe that's how ballistics work. I don't believe that when you see a target, it's not really there. When you see a target, it's really there. Like it's not because of refraction. You can't see a deer behind a mountain or behind a hill. And all we're saying is what we're seeing is what's actually there. And the globe earthers are going, nuh-uh, what you're seeing is actually refraction, right? But then you ask them what kind of refraction, and tell me what kind of mechanism is causing this, and how do we verify this? And nobody knows anything except for the word refraction. They just dismiss it with refraction, and that's not quite how it works. It's kind of like saying, if, let me think how to put it. It's kind of like when someone says, "Oh, you're a conspiracy theorist. I don't have to listen to you. I can just dismiss everything you're going to say." Well, that's two tactics really. That's stultification, right? And it's another one that I can't remember right now.
But to further expand on your question, Shogun, about how people can get involved with this too, is simple, like camera too. They have these cameras now. You get the Nikon P900 or the P9000. These long distance cameras. You can go out to spots. You can, find objects that should be hidden. Tall mountains that should be hidden by the curve. Tall landmarks or just other things in general too. It's not much. These cameras aren't too expensive, but these are things you can do yourself.
Thank
Yeah,
you.
just with the Earth curve calculator, anybody can do this. I mean, even if, well, I don't know about other states, but in Texas, you can drive on the beach. I mean, even if you just drive up to the beach and turn on your lights at a cove, right? And then someone's in the water, right? Or on the beach, right? If, you do the math, right? It's really easy to plug the numbers into the Earth curve calculator, and they're going to calculate refraction and all that stuff for you. It's really easy to just punch in the numbers.
Can you do the same with binoculars, not just a camera, like a high-powered lens or something?
Yeah, you could use lasers, binoculars, telescopes, high-end cameras, right? There's lots of stuff that you could do, but what you're trying to do is you're trying to falsify or prove that there's curvature. Now, I've already demonstrated with the Skunk Bay time lapse that you can have false horizons due to atmospheric conditions. So if you see a white swan, this isn't like a one-time measurement type deal. What we're seeing is black swans all over the world. People are seeing stuff they shouldn't be able to see. So if you get a white swan, I'd say just measure it again. Just keep going back to the same spot and measure it. And, the thing is that it should be done like over a matter of, in my opinion, as much as possible. You want to test it as much as possible. But I went out there the first try on 4th of July, right? Really steamy day in Texas. And I seen it during the day and I seen it at night. So with or without the sun perturbing the atmosphere, I still seen it with my naked eyes. I could see the buildings. I could see the white paint, right? And then I could see the lights.
Well, this has been a lot of great material, a lot of good information. Does anyone else have a question or a comment they want to get in? If not, Hank, thank you so much for your time and for your knowledge. I was just wondering, do you have maybe like a takeaway message or a parting thought you want to leave with the audience here in the room and also those listening later on YouTube and BitChute?
Yeah. Think for yourself, question authority, right? And if everyone were governing themselves, would they need to be governed from without, from the outside? So if you govern yourself and everybody follows natural law, then people can't stomp the breath out of other people and other people get pissed off and riot and steal stuff and burn stuff down. If everybody would just follow natural law, then, the society would be a lot better off. So, take a look at the 10 Commandments. It's pretty easy to follow. I mean, all you have to do is love your neighbor, and if you love him, you won't steal his wife or his car or his life, and you'll be cool to your parents. And, that's all it takes. Love conquers a multitude of sins. So, yeah, don't believe anything that you see, especially if you see it on TV, right?
Wise words from a wise man. Thank you, Hank Hill, again for your time. Thank you to the live audience and everybody who came to listen to the podcast. We do these podcasts every day pretty much. We'll have them usually at 9 p.m. Central Time. We'll have one tomorrow on the subject of distilled water urine therapy and the God complex with Destrix. But you can see on the announcements channel, there's always new events coming up. And all the past special events, debates, interviews, etc., can be found in the hashtag RT podcast channel. All the channels have different, YouTube channels have different episodes, so check them all out. Like, follow, subscribe. Thanks so much, guys, and God bless.